Hey, Kamaya.
Okay, I can hear.
Okay, you can hear me?
Yes, ma'am.
Okay, great. There was one other student supposed to join. I sent her the link too, but I can just film this and send her the video so she can see what we went over.
Okay.
Do you just need part 4 or do you need help with the entire project?
I would like to go over the entire project.
Okay, perfect. And then do you have notes, like a piece of paper and a pencil or a pen and your calculator close to you?
I don't have a calculator, but I have a pencil and paper.
Can you, do you have a calculator on your phone or like the Desmos app on your phone? That'll work.
Yes.
Okay, perfect. Then I'm gonna share my screen and we'll start off with a few basic matrices problems and then we'll move into the project.
Okay.
All right. All right, my document camera is crazy, so let me see if I can get it focused. Okay, there we go. All right, so, and just stop me if you have a question or if I'm moving too fast.
Okay.
Okay, so with multiplying matrices, the order matters. So here, what you're gonna do is you're gonna take the first row and we're matching it up with the first column. So to figure out what those numbers are, we're gonna do 2 times -10. So I'll do 2 times -10 plus 5 times -1. And then we just keep moving down the rows. So we have one more row. So let's go ahead and look at this one. I'm gonna do -3 times -10 because I'm still matching it up with this first column plus 7 times -1. So let's go ahead and figure out these numbers. All right, I like to take it just one step at a time. So we'll do the 2 times -10 would give us -20 plus 5 times -1 would give us a -5. And then the -20 plus a -5 would give us a -25. So I know if I'm multiplying these two matrices, my first number up here is going to be -25. Are you good with that piece?
Yes.
Okay, cool. So then let's simplify this right here. A -3 times a -10 will give me a +30. And then a 7 times a -1 is going to give me a -7. When I add these two together, I get 23. So I'm going to put that right there. Good with that?
Yes.
Okay. Sorry, making sure that I am. Okay, I made one small mistake. I'm sorry. You put it right here. This is the first time I've worked with matrices because I'm usually a geometry teacher. All right, so you put it right there. So we're lining it up like we did this first one. Does that make sense?
Yes.
Okay, cool. Now we only have one more column to do. This column, 2 and 8. So we'll do the same thing we did here. So 2 times 2 plus 5 times 8. So that's the first row. All right, tell me what you think the second row will be.
-3
Yep.
times 8
times 2. We'll go with the first one. So -3 times 2 plus
times 2 plus 5 times 8.
7 times 8. See that 7, right? So we're looking at this row and this column. So 7 times 8. We can do one more together too, just to make sure that we got it. All right. So when we're simplifying these, 2 times 2 is 4. 5 times 8 is 40. Which would give me 44. So I put that right here. Negative 3 times 2 gives me a negative 6. And 7 times 8 gives me 56. When I add those together, I get 50. So here's my matrix. And then I also found a website that will check our work. So I'll send you that website because you'll have to show your work with the project, but like you can check and see if you have the right answer on the website. So I'm going to go ahead and pull the website up so we can check our work and make sure I didn't do anything wrong. So give me 1 second. Okay. And I'll just email this to you.
Okay.
All right. Can you see the website on my screen?
Yes.
Okay. So I put in the first matrix from our work, 2, 5, negative 3, 7. And then I'll move over and put the second matrix in for B, negative 10, 2, and negative 1, 8. And then right here under C, I just put what I want to do, which will be A times B. So I'll do this matrix times this one, and you hit the evaluate button, and it should give us the correct answer up here. Is this what we got? Negative 25. Oop. Okay, so I was right the first time. I'm sorry. Do you see how the 23 is below the negative 25?
Yes.
Okay, I'm sorry. Again, this is I haven't done matrices since college, so this is a long. All right, my bad. So negative 25, 23, 44, 50. So you do line it up like that. All right, we'll do one more for practice for you and for me.
Okay.
So let me make up another problem and we will go through it together. All right. Okay, I'll give you a second to write that down.
It's still focused. Oh, there it goes.
Okay.
Okay.
All right, so we always take the rows of the first one and the columns of the second one. If I can spell column, I cannot.
So it'd be 3 times 9.
Yep, plus.
Plus 8.
Yep.
Times negative 4.
You got it. So 3 times 9 is 27. 8 times negative 4 is a negative 32. When we add these together, 27 minus 32, you get negative 5? Okay, perfect. So we'll put negative 5 there. All right, and now what about the next one?
You would do 5.
Yep.
Times 9.
Yep.
Plus negative 2.
Yep.
Times negative 4.
Perfect. All right, so that's going to give me 9 times 5 is 45 plus 8, because a negative times a negative is a positive. So that's going to give us 45 plus 8, 53. All right. Okay, and then we're ready for the next one. So we're gonna keep doing it, start off with the same row, but move to the next column.
Okay, so it'll be 3 times 0.
3 times, yep, you're right, sorry. 3 times 0.
Plus 8.
Yep.
Times negative 6.
All right, perfect. 3 times 0 is 0, plus a negative 48. So that'll give me a negative 48. All right, and then the last one?
5 times 0 plus negative 2 times 6, -6.
You got it. All right, so 5 times 0 is 0. -6 times -6 gives me, or sorry, -2 times -6 gives me +12. All right, let me check it on that website just to make sure we did it right. So let me go back and put it in. All right. So my first one was 3, 8. My second one was 5, -2. All right, and then 9, 0, -4, -6. And I want to multiply, so I just hit evaluate. All right, we got -5, -4. Yep, we did it right. All right, nice job. Okay, so I think we are ready to move to the first part of the project, part 1. All right, let me get my document camera back on. Okay. All right. So the only difference with part 1 is now that instead of 2, we have 3, but we're just doing the same thing. It's just an extra step. All right. So it says select any 2 matrices to prove that matrix multiplication is not commutative. So when it says not commutative, it's basically saying normally with multiplication, order doesn't matter, right? 2 times 6 is going to give me 12, and 6 times 2 is going to give me 12. But with matrices, the multiplication order does matter. You'll get 2 different answers. So if I multiplied matrix A times matrix B, it would not be the same thing as matrix B times matrix A. So you can't say the 2 things are equal. So basically what part 1 is trying to tell you to do is pick any 2, and we would do A times B. We'd figure out what the answer is, and then we do B times A. And since they're different, that would mean that matrix multiplication is not commutative, right?
Right.
So do you want to multiply one out? Do you want to work the whole thing out, or what do you want to do?
I want to work the whole thing out.
Okay. All right. So I'll walk you through multiplying the first one, and then I want you to try the second one on your own, and I'll check your work.
Okay.
Okay. So yeah, sorry. It always does. It just automatically, hold on. Okay. Which 2 do you want to do or want to multiply?
B and C.
All right, let's do B times. So the first one that I'm going to do is B times C, and then you'll do
B times B.
Around. Yep.
Okay.
All right. So we'll start off with B first. So 5, -6, 3, -3, 7, 2, -1, 4, -2. We're going to multiply that by -2, 3, 5, -7, 4, -6, -5, 1, -3. Okay, perfect. Rows on the first one, columns on the second one. All right. So I'm going to look at my first row here and my first column here. So I'm going to do 5 times -2 plus -6 times -7 plus 3 times -5. And you saw where I got all those numbers from, right?
Yes.
Okay, cool. All right, so then I'll simplify it step by step. -10 plus 42 minus 15. All right, let me put that. -10 plus 42 minus 15, 17. Okay, I'll put 17 right there. All right, time for the next one, and I keep moving down the rows before I switch columns. So what will be next?
Wait, which one are you? Oh, -3.
Yep.
Times -2.
Perfect.
plus positive 7
Yep.
times negative 7
Yep.
plus negative 1.
Where'd you get the -1?
Wait, I mean plus, wait.
You did this one, this one.
I mean 2.
Yep. There we go. Times.
Negative 7.
You mean -5, right?
I'm confusing myself. Did I already do negative 7?
Yeah, you did -7 here with the 7 times -7.
2, 5, negative 5.
Perfect. And so when I was working these out on my own, I realized I saw a pattern. So you can actually like see how it's times -2 times -2. So you know I can just drop down each of these numbers right here. See how it looks on the paper?
Yes.
And then you can just fill in the last row. So this first blank, I'd put in a -1, right?
Mm-hmm.
The second one, I'd put in 4, and the
4,
last one, I put
and
in
then
-2.
negative 2.
Because I was doing the same thing. I was getting myself confused, like, wait, what number am I at? So I just ended up writing down like each of the column numbers like that, and then just plugging them in for each row.
I think it's easier that way.
Yeah. All right. So -3 times -2 is 6, plus a -14. Ooh, I'm sorry. That's a -49. 7 times 7. And then plus a -10. All right, let me add these up. 6 minus 49 minus 10. Right, and again, -53. All right. +2 plus a -28 plus 10. All right, so 2 minus 28 plus 10 is a -16. All right. We're ready for our next row. All right, so what is first?
Well, we already did that. It would be -3.
Yep.
-3 times 4 is times 3.
Yep.
Plus, wait. Okay.
Wait, I'm sorry. I got you confused. I'm so sorry. We're back up at the first row and we're doing the second column. That was my fault. I'm sorry. So you're
Okay.
5 times 3. Yep.
And then plus -6
Yep.
times 4
Yep.
plus 3 times 1.
Yep. I'm sorry about that. And so you can go ahead and fill in these column numbers, the times 3, the times 4, and the times 1, because those won't change. And then we'll just drop in each row. So we've already done the first row. So what am I dropping in here?
What's that? Oh, -3.
Yep. And then
7
yep.
and 2.
2. Yep. And then on the last one?
-1.
Yep.
4.
Yep.
And -2.
Perfect. All right. All right, I got -6, 21, and 11.
Okay, I'm ready for the next one.
Okay, cool. Let me. So now we're going back to the top row, but we're doing the last column. So what? I'm gonna move the paper up. Do you have the original problem written on yours, or do you need to see it?
Yes, I have the original problem.
Okay, cool. All right, what's the first one?
Oh, you do 5
Yep.
times 5
Yep.
plus -6
Yep.
times -6
Perfect.
plus 3 times -3.
Perfect.
Oh, wait. Oh, no, I was right. -3 times
-3 times 5, and then
plus -1 times -6.
wait, where do you get the -1 from? If we're going by rows, right? So after the
Oh, wait, I meant 3. I was going by columns. I meant 3.
okay, columns in the second one, but rows on the first one.
I meant 3. -3.
All right, so -3, then
Wait. Wait. 5, 6, 3. Oh, 3, 7.
yep.
Plus 2
Perfect.
times -3.
Yep.
Wait, I lost myself. 3. -1.
Yep.
And then 4.
Perfect.
And then -2.
Perfect. All right, let me work these out.
Times 5, 4, 6, 2, 3.
All right, these are the 3 numbers I got. Did you get the same thing?
And 23. Yes, I'm finished.
Okay, cool. So you got 52, -63, and -23?
Yes.
All right, perfect. So I'll let you get a head start on the next one while I check our work on that website.
Okay.
All right, so I'm going to make sure that our work here was right, and then you're just going to switch them and do this one first and then the next one. So you're good with how to set it up?
Yes. So on the second one,
Mm-hmm.
when I get to the third row, I would do. Wait, I'm confused. Okay, so on this one we did rows. B was the row. I switched it, so C would be the rows and B would be the column.
You got it.
Okay.
Right. I'll check our work. Okay, we got it right. Let me know whenever you're done, Kamaya.
I'm finished.
Okay, so what'd you get?
I didn't finish the third one, but the first column, I got 24, 41. No, the first row, I mean.
Okay.
I got, and 25.
I got those, except I got them as negative numbers. You didn't, did you get negatives or positives?
Positive.
Let me see. All right, here's my.
I probably did something wrong.
Okay.
I didn't, at first I didn't have -2.
Yeah, I messed up on that on my last one. And so that's what I went and checked the work to see if I was right, and one of my numbers was messed up. So like literally the smallest little mistake affects the whole thing. But here's what I got, and I checked it in the system, so I had to change one of my numbers. But so basically what the final answer for part 1 will look like is this right here. So we did B times C before, and this is what we got, right?
Okay.
And then we did C times B, and this is what we got. So basically we're saying that B times C does not equal C times B. So matrix multiplication is not commutative. So that's like this plus the work is what we need for part 1. So
okay.
So I guess if you just go back and check your work against mine and then correct any errors, you'll be set for part 1. Okay. You ready for part 2?
Yes.
Okay. All right. Original paper. All right, part 2, select one of the matrices to find the inverse. All right.
Hold on. Click back up part 1.
Oh yeah. Like the final answer, or what we got for like this right here?
Yes.
Okay. Hey, you can come in. Yeah. Yeah, well, I'm doing a session, but you can come in. Sure, video? Yeah. But not me.
Okay.
Oh, they see me?
I don't know. My husband's being weird. I'm sorry, he just walked into the room. All right, so you got everything for that?
Yes.
Okay. Let me go back to part 2. All right. Select one of the matrices to find the inverses. Prove their inverses. So there's 2 parts to this. Number 1 is finding the inverse. So there's a formula for it. So every matrices is lettered like this: A, B, C, D. So like for this very first one, what number would represent A?
Wait. 1.
Yep. And B is -2, and so on. So the inverse, so let's say this was matrix A. The inverse of matrix A, which we designate with like a -1 exponent like that, there's a formula for it. So you basically take each of these letters and you do this: 1 over A times D minus C times B times the matrix DA. So you switch these 2.
And those 2.
Yep. Is this ringing a bell, kind of?
Yes.
Okay, great. So let's do a quick inverse practice before we get to any of these.
Okay.
All right. So let's say 2, 4, -5, and 0. All right, so if I want to find the inverse of that, I would start off by multiplying it by 1 over what?
Wait. You said 1 over AD?
Yep, A times D. So what would A times D be?
2 and 0.
Yep, so 2 times 0 minus C times B, which would be
1.
I got negative 5 times 4, right?
Yes.
Okay.
I need to write down the formula.
I know I had to write it down too. All this like matrix operation stuff is a ton of steps. And then here we switch A and D. So I'll put the 0 in the top left and I'll put the 2 at the bottom right. And then I change the signs of B and C. So now instead of a positive 4, this will be a negative 4.
And that would be a positive 5?
Yep. So all I have to do is work this out. This is going to be 1 over 2 times 0 is 0 plus 20 because the two negatives make a positive. So this is the same thing as 1 over 20. Now what I do when I have that on the outside, to multiply, I basically just multiply everything in the matrix by that 1 over 20. So I can keep it as a fraction. So anything times 0 is obviously 0. I'll put 5 over 20 here, negative 4 over 20 here, and 2 over 20 here. And those can all be reduced, right? But we won't go into that now just because I want to keep it moving on the project. But that basically you just multiply each thing by what you get here. So what you're going to do is pick one of them to create the inverse. So I'll go ahead and let you pick one. I want you to calculate the inverse, and then we'll check your work.
Okay.
Just let me know whenever you're done.
All right. Do F.
You said you picked F? You picked F to do?
Yes.
Okay.
Supposed to be 2. I think I'm finished.
All right, what'd you get?
I got -3/2, -5/2, 2/2, and 4/2.
Perfect. That's what I got too, except so you can end up the 2/2 you can just write as a 1.
Put 1.
And the 4/2 you can just put 2. Perfect.
Okay.
All right. Now, the second part of this says prove they are inverses. So basically what that means is if you have two matrices that are inverses, when you multiply them together, you end up getting the identity matrix as your answer. Did you guys talk about the identity matrix at all?
I don't know.
Okay. Identity matrix is basically the matrix equivalent of the number 1. So you know when you're multiplying anything times 1 is still itself. Like 5 times 1 is still 5, 10 times 1 is still 10. Well, the identity matrix, any matrix times the identity matrix stays exactly the same. So the identity matrix is 1, 0, 0, 1, like that. So to prove that these two are inverses, we'll have to multiply the original matrix and the matrix that you got, the inverse. And once we multiply them out, we should get the identity matrix if they're actually inverses.
Okay.
So do you know how to set that problem up, or do you need some help setting it up?
So would I do everything like -3/2 times
Yep.
1 and like okay.
Yep. So you would start off with your first one and you would multiply it by the one you got. 1, 2. So you would do rows and columns. So you would do -4 times -3/2. And you can you use your phone calculator, or you can just multiply the two. Yeah, you got it. So I'll go ahead and start working this out too. But you're just basically multiplying these, and we should end up getting the identity matrix if they're actually inverses.
Okay. Okay, I think I'm finished.
All right. Did you get the identity matrix?
Yes, I think I got it. But no, wait. No, I didn't get it.
All right. Which one did not equal what you thought it would?
-5 times -5/2.
-5 times -5. Okay. So here with so you did 4. So on this first one, I did -4 times negative. Oh, you're talking about the second one. Right?
Oh, I didn't do this right.
Okay. Do you see how to, does my work make sense?
Yes, I didn't do this right. I just went straight multiply across.
Okay. I'll give you a second to look over that, and then we can move on to part 3.
Okay. Yeah, I didn't do it right.
I know I had some trouble too. I'm like, we literally just stopped multiplying, and now I can't even remember it.
But I did get 12/2, and then I got, wait, yeah, and that's where I messed up at.
Okay, so then 12/2 is basically the same thing as 6, right? Because 12 divided by 2 is 6.
Yeah.
So 6 minus 5 gives me that 1.
Okay, I got it.
Okay. All right. Part 3, select a system to solve, indicate which one you've chosen, and then solve it. So let me get some scratch paper. All right, I'm not sure which way you learned in class, but I'll tell you, I'll just do the way that makes most sense to me, if that's okay with you.
Yes, I wasn't there when they learned this. I think this is the thing that I meant.
Okay, gotcha. All right, sorry, I'm trying to focus my document camera. Do you remember solving systems of equations from Algebra 1?
No.
Okay. What the heck?
I probably know how to do it. More than likely, I know how to do it.
Okay, cool. Well, then as soon as I get started, just let me know if you want to stop or move on or what. But with a system of 3 equations, we have 3 different variables. So basically the hard part is just going to be finding one variable, and then after that, we'll be able to plug back in. So to do this, start off by just combining the first 2 and the second 2. So I'm going to rewrite -x minus 5y plus z equals 17. Then -5x minus 5y plus 5z equals 5. So I wrote out the first 2, and now I'm going to write the second 2 together off to the side. And you'll see why in a second. Okay, so these are the first 2, these are the second 2. I haven't done anything with them yet. To solve, what I want to do is get rid of the extra variables until I only have one variable left, and then that will make it really easy for me to find what it is. So to get rid of a variable, we're going to use the elimination method to cancel it out. So I need to get rid of the same variable in this set and in this set. Now, looking at this, can you see a variable that will be eliminated automatically if I add these two together?
Is that a, wait, is that a Z?
This is 3Z.
Mm-hmm.
So if I add
what will be eliminated is negative 5y and positive 5y.
Perfect. So we're eliminating the y's in this one. So let's just go ahead and add the other two. A negative 5x plus 2x is going to give me a negative 3x. And then 5z minus 3z will give me 2z. And then 5 minus 10 will give me a negative 5. You good with all that?
Mm-hmm.
All right, now the y's don't automatically eliminate over here, so I need to multiply the bottom equation by a number to make sure they eliminate. So right now they're both negatives, but I need to make this one a positive, so it will automatically go away. So I'm going to multiply the entire equation by a -1, because that will get rid of that negative, right?
Right.
So I'm going to go ahead and multiply every single term in there by -1. So -1 times a negative 5x will change the sign to a positive. It'll change the y sign to a positive, and it will change the z term to a negative. And don't forget the last one, that positive 5 will become a -5.
Okay.
All right, so once we did all that, I'm just going to move the original equation below it, and then we'll combine them. All right, so now you can see that the y's eliminate out because they're opposite signs.
Mm-hmm.
All right, so when we add these two together, we'll get 4x. When we add these two together, we get a -4z. And then these two will give me 12. All right. So now we have these two equations. I'm going to line these two up over each other and see if we can eliminate out another variable. So 4x minus 4z equals 12. And -3x plus 2z equals -5. All right, do you see any that automatically eliminate, or do we need to multiply one of the equations by a number?
Multiply.
Yep. So I think the easiest thing to do is to multiply the bottom equation by 2, because that will help me get rid of the z's, because 2 times 2 is 4. So I'll have a positive 4 and a -4. So if we go ahead and multiply every term by 2, this is going to give me -6x plus 4z equals a -10, because I just multiplied each thing by 2. I'll bring the original top equation down so that we can add them together and cancel out the z. And tell me if I'm moving too fast.
No.
Okay. So we cross out the z's because they cancel out. The -6x plus 4x is going to give me a -2x. And then the -10 plus 12 is going to give me a +2. So the last thing I need to do to figure out what x is, to solve for x, is divide.
Yep.
So 2 divided by -2 simplifies to a -1. So I have my first variable.
Okay.
So now I can take this and plug it back into one of these two equations to find what z would be. So which one of these two equations do you want to use?
The first one.
Okay.
The one at the top.
All right, so 4x minus 4z equals 12, and we're just going to plug in -1 for the x. So 4 times a -1 gives me a -4. All right, what's my next step here to get z by itself?
You have to multiply the bottom one because you're trying to get the two negative 4z's to cancel out.
Oh, I see what you mean, but we actually don't even have to do that because z is my only, like looking at this, z is my only variable. So I can go ahead and just solve for it by getting z by itself. So right here, the next thing I'd have to do is add 4 to both sides. And see how now we have negative 4z equals 16?
Yes.
And then what's my last step here?
To divide.
Yep, divide both sides by negative 4. So that would mean that z is equal to negative 4. And the only one that we're missing is the y. So I'm going to go back to one of the original equations. I'll just take this first one up here, and I'll write it down at the bottom. So negative x minus 5y plus z equals 17. And that's just from the original problem, right?
Right.
All right, so what are we going to plug in here? What variables do we already have?
We have negative 4 and negative 1.
All right, so I'm going to plug in the negative 1 for the x. So just going to plug in negative 1 right there. Minus 5y plus a negative 4 equals 17. Now we can just use algebra to solve for y. So this negative 1, the two negatives are going to cancel out and it will just become a positive 1. So 1 minus 5y minus 4 is equal to 17. Now I'll just combine the like terms, the two constants here. So 1 minus 4 is going to give me a negative 3. So negative 3 minus 5y is equal to 17. I'm trying to get y by itself. So I'm going to add 3 to get rid of the 3 using inverse operation. And I'm left with negative 5y is equal to 20. So now I need to divide both sides by negative 5, which means y is equal to negative 4. We did it.
Is it another part to part 3?
Nope, that's it.
Okay.
Did all that make sense?
Yes, but I just don't get how we had to go through all this to get y.
I know, I know. It's yeah. With the 3 equations, like the more equations you add to the systems and the more variables, the more time it takes. But yeah, that's all that. All right, and then the last one, part 4. Then we are done. All right, let me pull up my page that I was working on. All right. Okay. So part 4, select a matrix to solve, indicate which one you've chosen. So basically this is like a simple algebraic equation. Like if I did 2x equals 16, it's the same thing as saying 2 times what will give me 16.
Mm-hmm.
So x will equal 8. So what we're trying to figure out is this matrix times what matrix will give me this matrix. So we're basically trying to figure out what this is right here. The problem is we can't divide matrices. It's just not possible. So in order to solve, what we have to do is get x by itself. So we basically want to cancel out this matrix. Normally what we would do to cancel it out is divide, right? If we divided both sides by 2, we get x equals 8. Since we can't do that, what we're going to do is basically the same thing. We're going to multiply both sides by the inverse of this number, because 1 over 2 times 2 is just going to give me 2 over 2, right?
Right.
And this would be 16 over 2. 2 over 2 is the same thing as 1. And 1x can just be written as x, right? Because anything times 1 is itself.
Yes.
So what we want to do to figure this out is multiply both sides of this equation by the inverse of this. So remember how we got inverse back in part 2?
Yes.
All right, so first step is find the inverse of this matrix. So I'll give you a second to look back at your notes from part 2 and find what the inverse is. And I'll go ahead and work it out too, and we can compare our answers.
Okay. I gotta write down the question.
Okay.
Okay, I think I'm finished.
All right, what did you get?
I got 2 over 7,
Yep.
1 over 7,
Yep.
negative 1 over 7, and 3 over 7.
Perfect. Okay. So that's what I got too. So what we're gonna do is multiply that inverse. So we're gonna do 2/7, 1/7, -1/7, and 3/7. Is equal to okay, I'll explain what I just set up.
Okay.
All right, so we found the inverse, right? So basically what we're doing is right here is multiplying this 1/2 times 2 to cancel it out because it ends up being 1, right? Remember when we multiply two inverse matrices, it ends up giving us the identity matrix, which is the same thing as 1. So what I can do, if these two are inverses, they actually just cancel each other out. So I'm just left with x on this side. So if I'm left with x on this side, the only step that I need to finish is multiplying these two matrices on this side. Now it looks funny because one of them is bigger than the other one, but it will work. All right. So let me know whenever you're ready to start multiplying those two. I'm going to set it up on a separate sheet of paper.
Okay.
All right. Okay.
Okay, I'm ready.
Okay. Cool. All right, we're gonna do same thing, rows time column, but there's only one column, so it should be pretty easy. So the first step is 2/7, not negative. So 2/7 times a -11 plus 1/7 times 8. And then all we do is just move to the second row because there's only one column. So what will the second row be?
It would be 2/7.
Oh, we're on the second one now. This one, -1/7.
I thought that at first. So -1/7.
Yep.
Times -11.
Yep.
Plus 3/7 times 8.
Perfect. All right. So when I multiply these out, I'm just going to multiply this number by the numerator. So that's going to give me -22/7 plus 8/7. And then I'm just going to add across. So -22 plus 8 is going to give me -14/7, which we know will simplify to -2 because -14 divided by 7 is 2. All right, and then on the next one, -1 times a -11 will give me a +11/7 plus 8 times 3 is 24/7. And I'm just going to add the numerators and I get 35/7. And 35 divided by 7 gives me 5. All right, so we can use the website to check our work. So,
Okay.
Did you get the same number as me?
You put +2 in the box.
+2 in the box. Oh, thank you. -2. My bad. Good catch. All right, so if we did it right, then we go back to the original problem. And if I say 3, this matrix 3, -1, 1, 2, if I multiply it by the answer that we got for x, which was -2, 5, when I multiply those two, what should I get?
-11 and 8.
Perfect. So let me go back to that calculator and make sure we did it right. Okay. All right, so my A this time is going to be 3, -1, 1, 2. And and my B will be -2, 5. And I want A times B. Yep, we did it. -11, 8. All right, that's it. Sorry that was so long, but hopefully that helped.
Yes.
Okay.
Thank you.
Of course. And then just you can email me pictures of your work or whatever's easiest for you.
Okay.
All right, sounds good. Well, don't hesitate to let me know if you have any more questions, and I will put that grade in today after you send it or whenever you send it. You have until next week.
Okay. I'm going to send it today.
Okay, sounds good.
Thank you.
All right, you're welcome. Have a good rest of your day.
You too.
Bye.